Hi guys, in today's tutorial we will do the analysis of the skid, the pressure vessel skid. Please note that if you have Solidworks 2022 model version, so this video is for you or above model, as I'm just going to use this linkage rod connector feature in the analysis. All right, so this feature just started from SolidWorks 2022, 23 and 24. It's not in 2021 we don't have this linkage rod connector. All right, so if you have SolidWorks 2022 or latest version, then this video is for you, because this linkage rod is I'm going to connect this spreader beam to the skid from here, this eye to this eye. All right, so this is the pressure vessel I have just model. uh, Let me, it has almost empty weight 5,000 kilogram. Okay, so I'm going to suppress this. We know that this is a 5,000 kilogram and it will be applied the load on here on these three beams. So this is my skid. These are some sizes I have used, and the main HEB 260 I have used. All right, yeah, and with some cross I beams. This is the multi-body parts, and the spreader beam is 2.5 meter long. The same HEB 260 I have used with some stiffeners and the end plate and the eye. All right, so let's start. I have suppressed this pressure vessel in the analysis. So let's start. So this is treated as a weldment, but I will not use the weldment. So what I will do, treated all bodies as a solid. Okay, so I don't want the weldment feature. We will do the same for the spreader beam. Treated all weldment. Like it is already solid body treated. All right. So here this is our main connection. Here you will see linkage rod option. Right click. We will keep the same as a this global interaction component interaction. We will not disturb this or modify. So we just add this linkage rod here. So first we will select these three faces, inside face, and just we will assume 20 millimeter dia of this rod. Okay, it will accept only in the meter, so it will be 0.02. And here the pivot joint. This is the end one here, and the end two will be here. Same, same, yeah. No, actually, this is So we will put the rod here actually. All right. So we keep the same. Pin this. Hit OK. The same we will apply for the same connectors. Okay, so everything is by default. The point is the pivot, so it can move flexible easily. The end joint 2 will be here. Okay, so our linkage rod is set up perfectly as we need. So now we have to fix the geometry from here. This will be the fix. Apply gravity by default. Okay, and now the force. Here we change the unit to the metric, and I will add 5,000 kilogram force on these 3 beams. Normal. Here. So I will change here to the total because our pressure vessel will be the empty and it has a 5,000 kilogram weight, empty weight. All right, hit OK. Now create mesh. I'm going to make it, let's see, make it 100. Hit OK. Okay, so our mesh has been created. Now let's run the study. All right, so I think the analysis is almost done. So let's see the result. All right, so I think these results are not good. Uh, it should be go straight like here, not goes on this side. So okay, so we need to fix this problem. Let's go to the model and let's see the center of gravity. Here, okay. All right, so I think this is not zero. It should be the zero like z value. In the x direction, you see this is a minor difference here. It should be the zero. Okay. So I think that is the problem to make it on this side. It's a little, it's a little tilt when we do we run the analysis. So how we can fix this problem? So let's go to the skid. It is really minor if we because these results are on the scale. So if I double click here, if I go to the true scale, so let's see, it it will not make any difference. See, there is no much difference. We will see in the displacement. Animate. Okay, let's do this analysis animation. Let's do this result on the scale. True scale. Okay. Now, obviously we can see this is all area is red, and this red area should be in the middle, right? Not on the left or right. So, however, let's see. Okay, so technically we need the all forces reacted on the y direction, right? Not x or in the z. We know our pressure vessel in the middle, and it's all the center of gravity. It should be in the middle, right? So all load should be distributed equally here. Okay, so here what we will use, we go to the fixtures, click here, fixed geometry, go to the advanced. Now here we will control some direction, we will control some movements. We just need the result in the y direction, okay? So here first we have to control the spreader beam. We will select this face. So it's mean it should be not move in x direction and in z direction. So I'm going to fix this in x and z direction. The reference, I'm going to select this reference. All right. So I fixed in this direction. As you can see, the arrows pointing on this direction. So it is fixed on this direction. And also I'm going to fix in this direction, in Z direction. So here you can see I fixed this beam in this direction and in this direction, but I let it free in the Y direction. I didn't select this one. So I activate this and this. Sometimes this arrow is pointing here or there, so you have to select which direction you want to fix. All right. So now let's fix our skid. So we will go again, fixtures, oops, fixed geometry, advance, this face, this face, this face. So reference, I'm going to select this. So we will do the same thing here. I'm going to fix this all skid in this direction, in Z direction, and also, no, now it's showing in the Y direction. So we will not select this. Okay, just click here. No, we don't want this. So let's click here. So you see this. If I activate this, so it will be point here. So it's mean I'm going to fix this, the skid in X direction and in Z direction. All right, so we already fixed. So let's see the result again. So this, please note that this blue area should be in the middle somewhere, not on the end of the frame. So I'm going to run the study again. Actually, this analysis, the frame analysis, kit analysis, will be in the middle without fixing this because my center of gravity is little out. It should be actually in the center, so that's why. But technically, if we see the true scale, it is not showing anything. But really, your thread. The study is almost done. All right. So now let's see. Height. I think it should be okay now. All right. So now let's go back to the table. 1.8 millimeter, and let's do the automatic here now. Let's do the animate. I think that should be enough now. All right. So here you see, to just controlling the movement in the X direction and the Z direction, I just got the result in the Y direction, right? And let's see also the stress. Double click on this chart, go to the floating. Let's do automatic. Here you go. Okay. I think we have selected these faces for that. We use this as a fixture, but anyway, that's not a problem because it's all values are under control. Let's see the factor of safety. We have minimum 2.8 factor of safety. Double click on this table again, go to the floating here, uncheck this and make it the maximum value of 100. Also uncheck this. This is the minimum value. Let's make it the 0. So we got the table from 0 to 100 for the factor of safety. So here you can see. Alright guys, so this is how we can do the skid analysis of the pressure vessel using some fixtures and the linkage rod connectors. So this linkage rod connector is just available in Solidworks 2022 model and 23 and 24. It's not available in 2021 model. Alright guys, so please watch more videos on our channel and please do subscribe. Thank you.